A 5-gram sample of an oxide of bromine is converted to 8.39 grams of AgBr. Calculate the empirical formula of the oxide. So what is common between the oxide of bromine and AgBr? Well, both of them have Br, or both of them have bromine. So what we need to do is to find the mass of bromine present in both the oxide of bromine and AgBr. So we are given in the problem 8.39 grams of AgBr. We can convert this into moles of AgBr, and we can convert this into moles of bromine, and finally we can convert this to grams of bromine. So we start with 8.39 grams of AgBr. To convert this to moles, we need the molar mass of AgBr. So 1 mole of AgBr weighs 187.8 grams of AgBr. So the grams of AgBr will cancel. We are left with moles of AgBr. To convert moles of AgBr to moles of Br, we just look at the formula, the chemical formula of AgBr. So if we look at the formula of AgBr, 1 mole of AgBr contains 1 mole of Ag and 1 mole of Br. So 1 mole of AgBr contains 1 mole of Br. So the moles of AgBr will cancel. We are left with moles of Br. Finally, we need to convert moles of Br to grams of Br. So we need the molar mass of Br. 1 mole of Br weighs 79.90 grams of Br. So the moles of Br will cancel. We are left with grams of Br on top. And if we solve this entire thing, this is equal to 3.57 grams of bromine. So the 8.39 grams of AgBr contains 3.57 grams of bromine. Now the sample is an oxide of bromine. So when you say oxide of bromine, the compound contains oxygen and bromine. So the mass of compound is equal to mass of bromine plus mass of oxygen. So the mass of the compound is given, that is equal to 5.00 grams. That is equal to the mass of bromine, which we just solved earlier, 3.57 grams, plus mass of oxygen. If you want to solve for the mass of oxygen, you just need to transfer 3.57 onto the other side, and that becomes a minus. So 5.00 grams minus 3.57 grams is equal to mass of oxygen. And that is equal to 1.43 grams of oxygen. So, we just figured out that the compound contains 3.57 grams of Br and 1.43 grams of oxygen. Now, what we need to do is to find the moles of Br and mole of oxygen. So let's start first with Br. The molar mass of Br is 79.90 grams of Br in 1 mole of Br. So the grams will cancel, and the moles of Br is equal to 0.0447 moles. We do the same thing to oxygen. The molar mass of oxygen is 16 grams of oxygen in 1 mole of oxygen. So the grams of oxygen will cancel. We are left with moles of oxygen. So the moles of oxygen is equal to 0.0894 moles. So we just computed the moles of Br, that's 0.0447, and the moles of oxygen, 0.0894. To find the empirical formula, we divide the subscript by the smaller number of moles. So between 0.0447 and 0.0894, the smaller number is 0.0447. So we divide both subscripts by the smaller number, so 0.0447. And that becomes Br 1, and for oxygen, 0.0894 divided by 0.0447, that is equal to 2. So Br1 O2, or simply BrO2. So the empirical formula of the oxide is BrO2, and that is the answer to this question.